Good morning, good afternoon to everyone, and welcome to our cloud coaching session. Today we talk about Oracle DevOps service, and together with team, you will investigate how to use it, how to set up a DevOps build, and deploy pipeline building and update a microservice, all in our Oracle Container Engine for Kubernetes. One more note, and then I'm done. Everything you see in this call has a purely educational scope. So if you like to use our services further, feel free to connect with your sales representative. Also, if you watch any of our cloud coaching recordings in the future, and we do have a cloud coaching on demand page that we will share with you shortly on chat and on Q&A, where you can see actually all the sessions recordings. Bear in mind that if you do so, there might be some differences in the Cloud Console menu because we enhance our product on a regular basis. That was all on my side. Team, over to you.
Thank you very much, Violetta. Okay, so let me just take control of the presentation. Okay, can I just confirm that my screen is visible?
Yes.
Okay, excellent. So you can see the slide deck, yeah?
Yeah.
Brilliant, thank you. Okay, so as Violetta said, my name's Tim Graves. When I'm not at work, I am a keen skier. I love cooking, and I bear a certain resemblance to a very, very seasonal fictional character. I should point out that one is CG generated, but it's still pretty close to reality. I'm one of the cloud native specialists within the EMEA specialist team, as are my colleagues Mika and Alberto, who are helping out with the Q&A today. So let's quickly have a look at what we're going to be presenting today, and then we're going to go into the demo as well. So to start with, we're actually going to do things in a slightly unusual order. We're going to do a little bit of lab work first, and then we're going to do the presentation part. The reason for that is just that part of that process in setting things up and doing the first build takes about 5 minutes. So it just makes sense from a presentation perspective to fit that in. So we're going to set up a build pipeline, then we're going to talk a little bit about the DevOps service. We're going to set up a deploy pipeline, and we're also going to have a look at some of the surrounding OCI services and capabilities. So let's get to do it. Right, so everybody can see the Cloud Console, I hope. Right, brilliant. So this is the OCI Cloud Console. For those of you who have used, wrong button there. For those of you who have used the OCI Cloud Console a lot, you're going to recognize the look and feel here. What we're going to be doing is, to start with, we're going to create our DevOps service. Now, the DevOps service is one of the services that's bundled as part of OCI. It's actually a free service to use the DevOps service, but you do pay for the resources. So, for example, if you run a build, you pay for the compute resources for use that. If you use the Git repository, you use the storage resources and so on. But to start with, first of all, if we're going to create a project, we need to be able to communicate between the different elements of a project. Now, this is specific to the setup of DevOps. There's a whole bunch of other setup I've already done here in terms of creating a Kubernetes cluster and some other aspects that are covered in other things. And we have previously done sessions on how to create Kubernetes clusters and how to deploy services on that. Or if you want more details on that, as Violetta says, you can talk to your sales rep. They can arrange a call with myself, Mika, Alberto, or the many other members of our team. So let's go and create our notifications topic. So this is, right. So go to the application integration. So I'm creating this in a compartment. This is just our standard demo compartment called CTD OKE. And we're going to create a topic. We're going to call it TG DevOps topic. Whoops, so I spell it right. I should know my own initials. So create a topic here. Now, the topic is basically a communications mechanism. Now, I know that you will look at this and you say, but he hasn't set up a policy it says I need to set up. Setting up the policies is something that is a very configurable thing. You can go for full admin rights, which is what I happen to have here, or you can go for very, very discrete topics. If you want to learn more about topic creation, then you can go and you can look at that. I think I hit the create topic button. I hope I hit create topic button. Let's just have another go. Right. Okay, looks like it worked. create. Okay. Right, well, hopefully this will come up in a second. Come on. Slightly embarrassing if it fails on the first thing you do as part of the demo. Okay, let's just go back in there, and I'm just going to have a quick look at our projects list. Right. Come on. Hopefully our cloud account is cooperating. Right, great topic. Okay, just create it with a different name then. It may be sulking because I had previously created one with that name. Okay. Right. This is normally pretty quick. So, okay. Well, we'll give it a try and we'll see where we get to. Okay, so now I'm going to go and create the DevOps service itself. The DevOps project. This is part of a DevOps service. As I say, this is a free service. You just pay for the resources you use. So what we're going to do, we're going to create a topic here. We're going to call it, just for convenience, TG DevOps project. Let me just remove that space. Okay. Now, I need the topic that we just created. In fact, it did create them, the user interface just didn't update, so we'll choose the one that I originally wanted to use there. So we're going to select that topic, and we're going to create our DevOps project. So that's created our project. Now, one thing we need to do here is we obviously, when you do things like builds, you want to see what the outputs of a build are and so on. So we need to enable logging so that we can capture the log data to look at and see if there's a build problem or stuff like that. Okay, so I'm going to enable logging. Now, the reason we do this manually rather than automatic is because not everybody has the structure that we want in terms of the default logs. So just going to enable that. Going to create a log group, going to create a log stream for us. Okay. So that will take a second or two just to create that. And after that, we will then go and be able to see the details of our project. Now, the DevOps project has a lot of services and a lot of capabilities, right? So some of them we can see on the left. We have things like code repositories, build pipelines, obviously history around those, and the same for deployment pipelines. Environments where we're targeting our builds to. Artifacts are things that define what the outputs of a build look like before we deployment. External connections allow us to connect things to external Git repositories, for example. So you can use your existing GitHub structure if that's what you want to do, but still use this as a build process. Triggers allow us to trigger a build process automatically. Obviously, there's things like logs and metric sections and stuff like that that you can use to find out more detail. Now, we're not going to go into huge amounts of detail on all of these today. We're just going to look at the core features and capabilities. So first of all, we want to have some source code to build. And to do that, we need to have a Git repo. So what we're going to do is we're going to go in and we are going to create our Git repository. Okay. We're going to the code repositories and we're going to create a repository. Now, I'm giving this a very specific name. The reason is what we're actually going to do is we're going to move stuff from one repository to another repository. Okay. I'm going to leave the default branch the same, but just put a bit of description on here so we know what we've got there. Okay. And we're going to create that repository. Now, as I say, in this case, it's creating the Git repository within the OCI environment. You don't have to do that. You can, if you want to, use GitHub, GitLab, pretty much any one of the standard web-based Git systems. So this is not a requirement that you have to do, but you obviously have to have some kind of access to the source repository to be able to go and access that information. So that's created a Git repository. We've got a default branch of main. There's a whole bunch of information here as to how to access that repository if we want to. Now, as I say, we're going to be transferring some code from an existing Git repository here. So what I'm going to do is I'm just going to run a script that will do that. It's a bit boring watching me type a whole bunch of commands. And I'm sure that you all know how to move stuff around using Git. So let's just transfer that repository. Oops. That's not what I expected. Right, let's have another go. Right, so apologies there. What's actually happening is we're downloading a Git repo. We are then going to set up some SSH keys and we're going to upload it to the new location. Okay, so this is all pretty much standard stuff here, does what you would expect. Okay, now, let's say apologies for that brief glitch there. So if we now go into our Git repository, we can see that we have a whole bunch of files here. This is basically the stuff that we had from that original Git repository. Okay, we can, if we want to, go and have a look at all of our source code and stuff like that. One of the things I'm going to look at here is we're just going to show you what our build spec looks like. So the build spec is the process for how we go and run the builds. Okay, there are a number of features in the build spec here. Okay, let me just shrink that one down. Okay, for example, it says who it should run as. It provides some definitions of environment variables that can be used to transfer between different build stages. Vault variables allow us to pull in configuration information from outside the environment. So, for example, if you had a database password that you needed to do as part of the testing, you could store that in the OCI vault and then bring that in based on the OCI ID of that secret. So you could change it over time. Exported variables are variables get passed on to different stages in the process. And then we have a bunch of steps. Now, the steps effectively are little bits of script, runs in a bash script that does various bits and pieces to build the environment. So, for example, at line 81, I am extracting the version number that is in the code, which will then be stored in a variable that's used at various stages in the process. Okay. Later on, I do things like installing the right version of Java, the specific version I want for the lab I'm doing, and so on. So there are a whole bunch of steps here, pretty standard elements here. Obviously, there's a lot of other things here. This is Java code. This code was written using something called Helidon. Okay, so you've got a whole bunch of Java programs in here. Let me just show you this. So this is a file we will be editing, which is our status file. And as you can see a little bit further down here, at the moment, we have a version of 0.0.1. We will be changing that shortly. Okay, so what I've done here is really just set up our Git repository. Now let's actually start configuring things. Now, as you saw a moment ago, the build spec has some settings for our vaults. And what I need to do is I need to tell it what the identity is. Now, what I'm going to do here is I'm going to edit that using the Cloud Shell. If you've not used the Cloud Shell, I can thoroughly recommend it. It's a really useful piece of technology here. Basically, it's a little micro virtual machine that runs within OCI. And what I'm going to do is I'm going to, first of all, get my vault variables. Oops, sorry. But before I do that, rather, I need to update my Git repository, because of course you don't ever update the main branch in Git. You always update on a working branch. So I'm going to create a new branch in my Git repo. And just to confirm that we've got that branch, because I was a little bit nervous that something weird is going to happen with Git that I'm not expecting. I'm going to check that it's actually gone to that branch. Yep, and we can see that my lab branch is now selected. Okay, so first of all, I'm going to copy the build spec from, if you like, the template to the default location. I could run it in a different location if I wanted to. But what we're going to do is we're going to go down in here and we're just going to edit the variables for our vault. Okay, so this is basically just specifying the vault variables for our system. So let me just copy and paste these from this window. Give me a second. These are way too long to try and remember. So effectively what I'm doing is saying that these variables will be set to the vault or the contents of those vault secrets. Okay. In this case, they're not actually particularly confidential, but it does mean that we can change the values without having to change the build spec again. Okay, so we've done that, and so what we can also do is we can just change our version number. Now, I'm just going to show you here. Our version number is set using, or we can check that it's set. It was originally 001. If I just run a curl command to talk to the version, you can see that it has reported it's 001, which is what we expect because that's a deployed command. What I'm now going to do is I'm going to edit the version number so that we can boost that a little bit, and we'll see later on that that change has been applied. Okay, so let's just change it to 1042. Okay. Now, of course, this is just changing the local version of the code. What we need to do is we need to make those changes. So I am going to effectively add those changes to Git and commit those changes to my local Git repository. And then, of course, I need to push those changes to the remote repository. Okay. So we can just go back in here. If I now go in and choose, oops, probably need to tell it that it's got a different branch. So if I go to my new branch, which is just what it's come up with, and we have a look in here, we can see the build spec I just copied over. And if I just scroll down in here, we've got the OCIDs and all of the stuff that we would expect to get. Okay, so that's just standard Git type stuff. It just uses the Git service that's built in there. Now, we have our source code. We need to start building it. So next step is we need to create a build pipeline. Now, the build pipeline is basically a set of instructions as to how to run the build. Okay, so to start with, we need to go and create our pipeline. And we are going to call our pipeline build storefront because this particular piece of software is a storefront. I should say it's a very, very simple storefront. It just does a tiny bit of business logic, but it's useful for demonstration purposes. Okay. And this is going to build our storefront service. Okay. So we've done that. And what we can do now is we need to give it those sequence of instructions, right? So first of all, we need to add a build stage. So our build stage is basically the thing that does the work for us. We can have multiple stages. We can have a build process, which effectively creates a small virtual machine to run the build process in. We could do things like trigger a deployment into the deployment environment. We can deliver our artifacts, which is outputting them from our temporary environment into a longer term storage. And also in some situations, you want to put a wait in, okay? For example, you're going to do something that depends on, let's say, a test process, and that test process relies on doing something else. So you can do a whole bunch of pieces like that, okay? So in this case, we are going to create an environment. I know it is saying I need to configure policies, but I am running with full admin rights here. Those policies are already set up. It will tell you the details of the policies if you need to do that. Now, what I'm going to do is I'm going to create a stage. It's going to be build the storefront itself. Okay, does the storefront build, and I'm just going to choose the default shape here. We could adjust these shapes to some extent if I want to. Other things I can do, I could, for example, connect it to a network that's running in my environment. Useful if I want to talk to, let's say, a local database for testing purposes and so on. I also need to give it the code repository. Now, in this case, we're using a local one, but as I said before, there's a whole bunch of other services that you can connect to. So we're just going to choose the local one that we just set up, and I'm going to tell it that I want it to work on my lab branch. Okay, so lastly, I just need to give it a name, okay, which we're going to call storefront. Okay, this is just for default naming purposes. Okay, you can have multiple source code names if you want to in here. So you could have, for example, one for source code and one for script code, for example. Effectively, it just allocates it as a directory. Okay, so we're going to say that that's okay if I don't want to allocate any others. So let's go and add that to our pipeline. Okay, so that's done a build for us. Well, it hasn't done a build. That's, I guess, part of the point. That's set up the sequence to do a build. So what we're going to do now is we are going to give it a build run. So in this case, we're going to do it as a manual run. Okay. We haven't set up any parameters, so we don't need to provide any manual inputs and so on. So we're just going to hit the manual run button. Okay. Now, whilst that is happening, I'll just explain a little bit what's happening here. On the left-hand side of the screen, this is the information for this particular build. So on the left-hand side of the screen, we can see the pipeline that we specified that was in process when the build was run. In the center of the screen, you can see the actual process. Now, what it's doing at the moment is it's getting a build runner. So it's creating a micro VM effectively. Once it's done that, it's then going to provision the environment into it. For example, setting up the software environment, downloading the source code and so on. Now, while it is doing this is going to take a few minutes to do that, mostly because it's got a huge Maven download to do. We're going to actually quickly go through and talk a little bit about why we do DevOps. Well, DevOps is really about the combination of an integration of the speed and reliability of a fast integrated service. So you make a commit, it goes in, it goes through, you can automate the whole process. And that's what the DevOps process that we have here is. It's a way of doing continuous integration and continuous delivery. Now, that doesn't mean it's happening all the time, but it means that these two are together. So every time you make changes, you can go through that process and you can have an automated testing sequence. This means that you don't have one developer who's got a huge amount of changes. You're continuously pushing back, so everybody's normally working on the latest version of the code. This also integrates very nicely with things like agile development. Now, why do we need it? It helps in terms of consistency. The automation gives us reliability and repeatability. We've got detailed accountability, so we can see obviously from all of the history what's going on. We can also do a whole bunch of automated security and testing processes as well. And it helps us with standardization. My build process isn't different from anybody else's because we're all using the same build sequence. So that means you've got, again, better consistency. Because we're doing this so often, it means that if there is a problem, we find it really, really quicker. And that's really important because you don't want to do a whole bunch of work and find you've got a big problem that takes a lot of work to fix. That means that the code is better and the releases are better. It also means that once you've released something, if there is a problem, you can fix it quicker, because the delta at each stage is much smaller. And those all together mean much more frequent releases. And from a business perspective, that means you're doing a lot better because you're responding to changes in your business environment quicker. So a typical environment that we would use here, you would run or build a pipeline, would run a build, that will generate some outputs. You can then maybe deploy it to a test environment, either as part of a build process or as a deployment pipeline, maybe a staging environment. You could have an approval process to say, yes, it works. This could include things like integrating with other elements like the security services and the vulnerability scanning. Once you're satisfied, you maybe have a manual process or an automatic process to say it meets your criteria, and then you deploy into production. And the beautiful thing about things like Kubernetes is you can do things like a rolling upgrade to keep these online all the time. So from a CI, continuous integration perspective, the service we're using is serverless, by which I mean I didn't have to set up, maintain, and build a server. When I ran a build, it creates the service for you. If you've got multiple builds going on simultaneously, let's say you're doing one and I'm doing one, those two builds can run concurrently. though obviously there are some levels of limits based on the resources you're allowed within your tenancies. It is fully integrated, so you can connect it to things like existing Git repos, like GitHub or GitLab, obviously the local ones as well, but it can also integrate to your entire environment. So if you have a database that you want to pull information down from, you obviously could create that within OCI each time you do a build, if you wanted to do so. One of those build stages could create a database for you. Or alternatively, you could have, let's say, a production database. You have to be careful here, obviously, but you could maybe read data from your production database to do some testing. So you can integrate into the broader environment, and it does give you a full stack sequence here. So you can connect the two together, you can trigger, you can deliver, you can manage secrets. You can even integrate this with external sources or external build processes. From a deployment perspective, we've got a whole bunch of deployment. So you can do blue-green, canary deployments, rolling deployments, and so on. You can, if you want to, run across multiple regions even. This is fully integrated, so we have a Jenkins plugin if you want to. You could use Jenkins to run your build process and deploy using the CI/CD tools. And we also have the ability to do an automatic rollback if there's a problem. Now, security is obviously very important. You're going to be getting a copy of these slides, obviously, as part of the information, but I wanted to specifically put some information in here. We have, as part of our container image service, vulnerability scanning and also digital image signing. Particularly if you're using things like Kubernetes, you want to consider digital image signing to limit what you can do to only those images that you've approved. But of course, to do that, you need to do it as part of the build process. Vulnerability scanning is also critical. You may be using a container image that's a week out of date and there's been a security vulnerability found in that image. The vulnerability services allow you to check for the most up-to-date elements in the CERT database. So we would recommend everybody does that. Now, we're not going to go into detail on this today. We don't have enough time, but I wanted to bring this up. Okay, so let's go back to our demo. Okay, now that build process has completed. Okay, and you can see in here, we've run to the bottom. It's done all of the various stages. If you had remember from the build spec, we ran various things, we extracted the variables, the names of the stages were, install, confirm variables, build source, pack, and so on. Okay, so all of that was done. And on the right hand side, we have the log data. Now, this is going to be huge because basically this is output from Maven for the most part. And as those of you who use Java a lot will know, Maven is very verbose. So, at the start, we've got a bit of information here. Then we've got all of our build output. I tend to be quite verbose in that I like to include in the log data things like the variables I extracted, because that helps me diagnose if there's a problem. I'll know which version it is. Notice that it extracted the source code, not the version from the source code, with that little piece of code there. Okay, so lots of options there. Let me just get rid of that wretched pop-up thing. It keeps on appearing. And then if we go all the way down to the bottom, we can see that it has saved our output. Okay, of course, all we've done here is done a build, okay, and that's great. But what we haven't done is we haven't saved those outputs anywhere or anything like that. So what we're going to do now is we are going to look at how we can take those build outputs and save them somewhere. Now, to do that, we're going to need to create a couple of repositories to store that information in. So first of all, we're going to create a container repository. The container repository holds our container images, as you would expect. And this is where we could do things like set it up so that it would automatically scan images and so on. So I'm just going to create a repository here. I'm going to call it TG DevOps Storefront. For reasons I will admit I don't fully understand, it tends to prefer at this point if you do lowercase repository names. I don't understand why, but it certainly seems to. So we're going to create that, and for ease of use, because I don't want to spend a whole bunch of time setting up image signing, image pull secrets and stuff like that, we're going to make this a public repository. Okay, obviously in a production environment you wouldn't do that, but again, that's stuff from the Kubernetes side of things. So I'm going to create that repository. Okay, and then I'm going to create the artifact registry. So the artifact registry is where we store the non-container artifacts. Okay, so there are a couple here. I was playing around with this previously. I am just going to create a new one here. We're just going to call it Demo DevOps. Okay, and we have the choice if we want to making an immutable artifact. Immutable artifact means you cannot change it for that combination of version number and artifact name. Really useful if you want to have provable, traceable history. For demo purposes, I'm going to disable that because we're going to be doing a couple of builds and I don't want to be changing the version number all the time. But if your version number was dynamically generated, for example, then you quite possibly would want to use immutable artifacts. Okay, so there we go. That has created our artifact repository. Now, something else we're going to do here is we're going to pass some artifacts into our pipeline. Now, or some information into our pipeline. Now, why are we going to do that? Because we want the ability to customize the pipeline without having to change it in detail. So we go back to the DevOps service and have a look at our pipeline. We have parameters, and I'm just going to give it a parameter. I'm going to give it a default value of TG. Default value is used for things like automatic builds. And we're going to give it a description here. Effectively, it's going to inject that into the pipeline, and we'll see in a moment why that's important. Now what we're going to do is we're going to put a new stage in our build pipeline, which will output our artifacts. Okay, and what do I mean by output our artifacts? Basically, what I mean is it's going to take them and pass them on to something else. So I'm going to add another stage here, and in this case, it's the deliver artifact stage. Okay. Now, our build pipeline says these are the artifacts at the very bottom of the build pipeline, and these are the names within the build process I want to do. So those now will get handed on. So we're going to create our version, or our stage, and we're going to call it upload artifacts to the external services, right? Now, I need to create the artifacts. Now, obviously I can script this, but for demo purposes, it's a little bit easier to just do this by hand. So I'm going to create a service, which is our YAML file that we're going to deploy. And this is a Kubernetes manifest. Okay. I need to tell it which artifact repository to use. So that's the one we did earlier. And I need to tell it where it's going to put it. So in this case, what we're doing is we're effectively defining the output location. So we're going to say the path is service storefront.yaml, and the version is storefront version. Now, this looks like a variable, and it is actually a variable. You may recall in our build spec, we actually extract storefront version. So effectively, the path name becomes a combination of the name plus the version details. And that will happen because we're using the substitute placeholders. Now, this also means that when we do the deploy, we can apply placeholders in there as well. Okay, and we'll see that in a moment. So I've done that. Now, unfortunately, I need to do this for a couple more of these. So I'm just going to create a new artifact, another one. So give me a second while I just do this bit. Now, the fun thing here is, or the fun, depending on your definition of fun, I suppose, OCI does allow you to set all of these up using the REST APIs. So you could put those in place if you wanted to. And there is obviously command lines as well, or Terraform. So you don't have to do this manually unless you really wanted to. Obviously, for this purpose, it's a little bit easier just to show you what's happening if I do it manually. But you wouldn't normally do this in a production environment because you would want things to be continuously reproducible. Nearly there. Right. Okay, so that has done all of our YAML files, but we haven't done the container. Now, the container is held slightly differently. It's not a Kubernetes manifest. So this is a container image. Now, what we're going to do here is we're going to put in quite a long string here. Okay. Now, this string, the OCI host is the variable that we extracted from a vault. Same with the namespace. Your initials is the pipeline variables that we injected, and version is the one that's generated for us automatically. So effectively, that whole pipeline will be created for us. So we're going to add that to that pipeline. Okay. What we've done here is we've defined, if you like, a template, however. This is not a real thing. This is just a template. Okay. So we need to connect the outputs of the build pipeline to the inputs or the place or the definitions we have just created. So what I'm going to do now is I'm just going to map these up. So we've created an artifact which is called service YAML, and we're going to connect that to the output of the build process called service YAML, and the same for all of the others. The reason for this is these things may not automatically have the same name. You may, for various reasons, want to do different things. Different outputs may go to different locations, so you might have production and test outputs and stuff like that. Okay, so let's add that stage. Now, that has set all of that up. Now, I'm not going to run a build here. I'm going to now go to the stage of creating our deploy pipeline, just for timing purposes, because we only have about another 15-20 minutes left in here. So a deployment pipeline is what it says. It deploys things into our Kubernetes cluster. Sorry, my apologies. Okay, so our deployment pipeline, we therefore need to know what that cluster is. So first of all, we need to deploy or define a Kubernetes environment. Okay, and I'm just going to create an environment here. I'm going to call it tg_ok. Now, you can obviously deploy this to other things, functions, or instance groups of compute instances if you want. And I'm just going to tell it to use the cluster that I created earlier. Okay. So that has created an environment. Effectively, we're linking the two together. Why do we do this? Because it means I can change the environment without having to change the details of my pipeline. Okay, so I'm going to create my deployment pipeline now. Okay, so as you would expect, this is going to be a pretty simple name. We're going to call it storefront deploy. I tend to try and use names that makes sense, to be honest, although it does mean they can be a little bit verbose. Okay, and we're going to add a couple of or three deployment stages here. Okay, so the first stage is going to deploy our deployment. If you have ever used Kubernetes, you'll know that you have deployments and you have services and you have ingresses, and generally it's an idea to get the deployment there and tested before you set up the service and the ingress. That will depend on your environment. Now, there's a whole bunch of options you can do here in terms of different deployment mechanisms, including things like running Helm charts if you're setting up environments where you need to have a known, let's say, version of the ingress controller. What we're going to do here, however, is we're just going to apply a manifest. Okay, we're going to target it to the environment we failed. We're going to specify an automatic rollback, and we're going to select the artifact, which is the deployment YAML file. Okay. We are not going to override the namespace, so we're going to let it choose its own namespace, and you'll see in a minute that we'll put that in as an environment variable. Okay, so we're going to add that one, and once we've got that, assuming that successfully deploys, what we're going to do is we're now going to add another stage, which will deploy the service. Okay. Okay. And we are going to select our artifact, which is the service. Now notice that it does include the version, okay? And where does it get the version? Well, it comes from a build pipeline, but when we connect the pipelines together, the variables get passed on, okay? So that is our service. I don't think that deployment will fail, but let's just put it in there to be on the safe side. And lastly, we are going to deploy our ingress controller. Okay, and the ingress controller is going to, as you would expect, update the ingress rule, which is, for those of you who are not familiar with Kubernetes, the mechanism whereby we connect an incoming request from the web proxy to the backend services. Okay, so there we go. We have added our 3 stages. Now, this is a simple pipeline. You may have seen there are an awful lot of options here. We can do things like wait. We could, for example, say we're not going to proceed until something else has happened. For example, we could write a shell script that goes and analyzes the container image vulnerability data to see if there's any high vulnerability stuff there. Now, I've mentioned briefly that we also need to talk about parameters. Okay, so parameters are something that we pass into the Kubernetes environment or into the deploy environment. So if I have a look at the parameters rather, I'm going to create 2 parameters here. One which is for namespace. Now this is a variable that's defined within my YAML files. Effectively, I specify the namespace in the YAML file, and I'm basically saying I want you to use the namespace TG. Okay, and when I created my Kubernetes cluster and the services, those are the ones that I set up. I also need to set it up with an IP address. This is to do with the way that the system operates in terms of setting up certificates and so on. This is purely because this is a test and development environment. That IP address is just a very temporary thing. It won't be there tomorrow, for example. So please don't pay any attention to that one. Okay, so I have set up those 2 pipelines. Now I want to connect the 2 together. Okay, so I need to set up or connect the 2 environments. So I'm going to go back to my build pipeline. I'm going to add a new stage, which will be to trigger the deploy pipeline. Add a stage, trigger deployments. There we go. So we are going to call, let's say we're going to call this one, sorry, my brain has just gone completely blank. Start storefront deployment. There we go, that'll do. Okay, and we're going to select the deployment pipeline, which is our storefront deployment pipeline. Okay, now we're going to pass on the parameters that came out, or the variables that came out of a build pipeline, and there are those parameters that are used. Those are the artifacts that are being used and being passed on. So it shows how all of these elements are connected together. So one last thing that I'm going to try and do here, I am going to set up a trigger. Because now we've got the ability for the build pipeline to do its work, then output the variables or the parameters, and then pass it on into the deploy pipeline. So I'm going to set up one trigger here, and that trigger is going to create a build for us automatically. Now, why do I want to do this? Well, because I probably don't want to come in and manually start the build each time. Okay, so I'm going to say it's monitoring on our repository. Okay, and the actions I want to monitor for are a push, and it's going to be my lab branch. Now, the reason I'm choosing a particular branch here is I could, for example, do this on a test branch rather than a main branch if I wanted to. I may have a different build process on that. Okay, so, oops, I need to tell it what to build, of course. Now, you could have different triggers, as I say, do different things. Okay, so we've done all of that. Let's go in and we're going to briefly edit our code again, and I'm going to change that version string now to what's today's date? 2024.3.27. Okay. .1 the first build today. Right. Okay, let's just go and add those. We're going to just put something different in here just to say that we've made a change. And we're going to pull that back into the Git branch. Oops. And that's not going to work because I hadn't hit create the trigger first. Oops. Apologies. Let's just go and do that quick sequence again. And we're going to make that version 2. Okay, so that's done the push, it's made the changes and so on. So if we go back to our project now and we have a look at our build history, we should, I hope, if I got the trigger right, just check that trigger was right, see a build starting off shortly, my lab branch. There we go. So this is a build which is being run because I hit the trigger. Okay, so it's going to do all of the steps we saw before, but you'll see now that there are additional stages. So there's upload the artifacts, which is taking them out of the build pipeline into the artifact repository and stuff like that. Then there's the start deployment. Now, whilst it is doing that, I'm just going to briefly show you some of the other things that we do have running here. This is going to take a few minutes. Okay, so first of all, we have a Kubernetes cluster here. This is a very small, very simple Kubernetes cluster. All it's really doing is just providing a couple of virtual machines to run our environment on. You may recall, if we look at the Cloud Shell, that I can talk to our services in the Kubernetes cluster, version 1.0. Okay. I also have a small autonomous transaction processing database that's basically providing us with information on how to talk to or storing our database and stuff like that. Okay. Now, at this point, as I say, the build process is going to take a few minutes. So let's just go back and we can have a look at how that is getting on. So we should see various bits and pieces happening. So we're actually in the compile phase at this point. So it's starting all of that. It can take a few seconds for logs to appear, by the way, because of the log service is a bit more batch driven, but it has successfully done that. Okay, so whilst this process is going on, I just want to take a quick pause. I don't see any Q&A in the system, but are there any questions? Okay. Yep. You can combine the two. So a typical environment, and Azure, Azure has a nice development environment. Don't get it wrong. A typical environment may be that you've got, let's say you're using, obviously I use a Mac here, but I'm basically maybe using Azure Git repos or something like that. Maybe I'm using GitLab, and so I can run SonarCloud and a whole bunch of services like that. You can absolutely do those services. So you can do that. You don't have to change your development environment either. You can continue to use your existing process. Now, we mentioned Jenkins before. There is a plugin for Jenkins that allows you to effectively upload the outputs of your build process from Jenkins into our repositories and to then process them and upload them and trigger a build sequence. Now, Azure is slightly different. There is, I believe, a plugin for Visual Studio Code if you want to do that. Mika actually knows more about that side of things than I do. But you can, if you want to, obviously upload artifacts. Artifacts is pretty much a standard file service. You can also obviously upload containers, which are standard Docker containers. So you could build your container in one environment, upload it into the container repo in OCI, and still get all of the benefits of the vulnerability scanning and image signing and stuff like that. You basically just have to make sure that your credentials are set up in your other cloud environments so you can pass that up. Any other questions? Okay, so you may recall when we set up our build pipeline, there was the option of saying connect to an existing service or an existing network and so on. You can obviously, if you want to, have a Terraform stage as part of your build process that will create a whole bunch of dedicated resources just for you. You'd start off with an empty network, if you like, and then you go and create a whole bunch of database resources or whatever other resources you needed. That's virtual machines, whatever. You could do that through Terraform scripts or OCI commands within your build stage. And then your build processes could then connect to those environments. Now, obviously, if you do that, you must remember to destroy those resources at the end, because those aren't being created by the build pipeline. So you need to have that automatic process. However, that's certainly an option. If you have existing resources, you could connect the build runners to an existing network that has these existing resources on it. Now, you're going to probably need to do things like inject the database ID or the database passwords into that, probably the wallet file and so on. So you need to think about how you're going to do that, but that is certainly a possibility there. Okay, so just to comment on this, so we've completed the build process. The upload process has been completed and it's now starting the deployment. So I'm just going to show you in our container registry here, if I go down here, that we have a container with the version number we specified. If we have a look in the artifact registry here, our demo DevOps, we've now got all of the artifacts we created. So if I go back to our deploy pipelines, can just quickly see how that is getting on. So this is our deployment. It's in progress. It's currently uploading and running the deployment on the manifest and so on. So that's probably going to take a few seconds. Just to show you, if I open the Cloud Shell, we can just have a look at our kubectl output. So for those of you that are familiar with the way Kubernetes works, you can see that we have multiple replica sets here. So we've got a new replica set that's now deployed. And if I go and do our curl command to get the status again, you can see that we have the new version. So that, ladies and gentlemen, is how we do that process. I'm aware we're at the top of the hour. I don't know if there are any more questions, Tom, that you want to ask or that have come in.
I think we're okay, dude. And I'll just see if there's any more come in.
Okay, thank you, Tim. Bear with me.
Thank you very much.
That was all on my side. Tim, anything else you'd like to add?
No,
or shall we just...
I hope to see some of you at the follow-up tomorrow. Please do join us. More than happy to try and answer any questions that you've got there. And obviously, if you do want a more in-depth session on not just the DevOps service, but any of the other things we talked about here, Kubernetes and so on, do please contact your local sales team, Mika, myself, Alberto, the rest of the team. We're here to help on these kind of discussions.
Thank you, Tim. Thank you, Mika, Alberto, for answering questions. Thank you, Tim, for this great demo and presentation. Thank you all for joining us today also, and we hope to see you soon again. Bye-bye, and enjoy the rest of the day.